So many friends today. Bob, Paul, hey, good to see you, Paul. Finally, we have Paul here and Santi. Hey, Santi, how are you doing? Thank you very much for joining today. You know, when the days are difficult, my mom used to tell me, look at the stars. So that's what we're doing today, looking at the stars in space and looking at the stars that we have in front of us here in the Zoom channel. Let's get the ball rolling. Ladies and
We'll say
gentlemen.
we do it like in opera. When the maestro comes on the scene, we clap hands.
Oh,
we
wow.
want to clap for you.
Oh, this is fantastic. Oh, it's the first time this happens to me, a virtual clap online. Ladies and gentlemen, welcome. Welcome to the epic online technology meeting on new space. I live in Noordwijk, ik woon in Noordwijk. So for me, it's actually a big deal to have this meeting with people from the European Space Agency. Hi, Iain, thank you very much for joining today. So I have a couple of things to tell you very, very quickly, like it's my style to speak quickly. So this is the 14 out of 31 meetings. We got completely crazy. We decided to organize 31 meetings in 8 weeks. This is the number 8. We are actually targeting every single topic that we thought it was interesting for the already 554 members of EPIC. We keep growing. I think all of you who are following every meeting, you see that almost every day I see a higher number. We keep growing. And I also would like to say that there is a lot of work behind the scenes. Sana and me, we are a little bit like rocking today the stage, but you cannot imagine how much effort all these people here in this slide are putting. This is people who from Monday at 8 o'clock all the way to Sunday at midnight, they are checking emails, they are answering, they are checking the slides of people, scouting new talent, scouting new companies that we want to have at the meeting. So I would like to also give them my applause to this great team. This is the dream team I always wanted to have, and finally I have. In every dream team, there are people with different roles, and I would like to remind that at EPIC we have 4 rising stars, each of them experts on a particular topic. So if you are looking for particular suppliers, partners, or customers, contact them. Contact Ana Gonzalez for PIC, for photonic integrated circuits. Contact Elena for medical and healthcare. Elena is actually on maternity leave until next month. Contact Francesca for the laser industry. And today we have Sana, space, quantum, and optics. And it's such a pleasure to have you, Sana, with EPIC. You're fantastic. When the whole situation goes back to normal, whatever normal will mean, we are going to continue organizing the meetings. I'm going to continue traveling 200 days a year. Nothing is going to stop that. And we already have great meetings planned for Q3 and Q4 and Q1 next year. And actually, we already have agreed to have the next meeting at the European Space Agency is actually in 2021 in September. So we are going back to organize a meeting at the European Space Agency. And all of you are members of EPIC, so you know that you should always constantly check the extranet and download all the market reports. I would like to remind you that we just spent a huge amount of money on buying this worldwide market for lasers report, which I strongly believe that is the best market report available in the laser industry. So you're looking for fiber laser diodes packaging, quantum technologies, medical, welding. This is the best laser report we have found. We have bought it and we have given to you for free. So use it, abuse it, do as much as you can with this. Finally, jobsinphotonics.com. We work also really hard on this. We are so proud of saying that this is now the biggest website for finding a job in photonics, www.jobsinphotonics.com. And with this is the menu. When I see the menu like this, when I see the agenda, I'm very happy because I have great speakers, but it doesn't mean as much to me as when I see the companies who have registered for the meeting. So we got something like 80 registrations. We have more or less assembled a supply chain with the different companies that go from the space companies and primes like Airbus, Antwerp Space, OHB, all the way to companies who manufacture either photonic integrated circuits, lasers, detectors. We have some LIDAR manufacturers today. We also have companies who are experts on beam shaping, micro optics manufacturers. Everyone has the right today to find partners, suppliers, and customers. I think we have the chances to have a great meeting. I would like to remind the people in YouTube, because we are actually broadcasting this meeting in YouTube. Many of you keep asking me, Jose, you forgot my logo there. These are the companies who registered to the meeting. I never forget any of my 554 friends. I never forget them. These are only the companies who registered to the meeting. If you want to participate in future meetings, please go to the website and register online. Please do that. Don't expect for me to invite you. You are invited by default because you're my friend. And for the YouTubers, so people on YouTube, if you want to contact any of the speakers today, and this is the most important part, if you want to contact any of the speakers today, send me an email, jose.pozo@epic-asoc.com, jose.pozo@epic-asoc.com. Send me an email and I'll introduce you to any of the participants today. This is valid for the YouTube people, but also for the people in the Zoom channel. If you want to interact with any of the participants, just send me an email and we'll make the introduction. And that's all I had to say, because the people who really matter today are the technology people. The European Space Agency has played a very big role with the EPIC, and inside the European Space Agency there is a star. There is my star. There is my friend. There is my Iain McKenzie. Iain, thank you very much for joining us this afternoon for your very shiny living room with the window next to you. How are you doing today?
Thank you for inviting me, and it's always a pleasure to be involved in epic meetings because they are epic.
You are epic. All of you are epic. But for me, the most important thing today is to understand what new space is and to understand how European Space Agency is looking at the whole supply chain. And look what a beautiful, beautiful supply chain we have for you. So I'm going to give you the floor now and the attention of everyone. All you have to do is share your screen and your ideas. You have to use the delicate touch. If you go in presentation mode.
I'm trying.
Yes.
Let's see if it lets me.
We are almost there. Both of us living in Northvik, next to the sea, but confined in our living rooms.
Why does it not go resume slideshow?
Perhaps you are sharing the wrong screen. Just go resume slideshow. That would work.
Let's try again. Resume slideshow.
Perhaps do you have two screens?
Yes, I do.
I think it's possible that you are sharing the other screen. So maybe the easiest thing would be to unplug the secondary screen. You don't need it. And then I think we'll be in business.
Actually, we see the presentation now. I think you can go on the presentation.
Yes,
mode.
now we're in
Excellent.
business. The floor is yours.
Okay, thank you. Thank you very much, Jose, and thank you for that kind introduction. My original brief was to say something about the qualification of photonics in the kind of new space environment, but unfortunately, I think that topic would not be possible in 6 minutes. So I've restricted myself to just giving an overview of what we think could be the interesting use of photonics in new space. So I would like to thank Nikos for also helping put together these slides. And with that, I'll move on. My name is Iain McKenzie. I work at European Space Agency, and I work in the optoelectronics section. And part of my role there is to prepare the photonics roadmap for future photonic technologies for space. So this is a really interesting area for us. And I'll just move on. So what is new space? It's very interesting. I mean, I think at the heart of new space is a kind of new entrepreneurial spirit. It's characterized by innovation. It's characterized by a new commercial and economic opportunity that's available in space. And I think there are a number of companies that are seeking to exploit space through this lens of a new economic framework. This is mainly due to the fact that new possibilities are there due to the cheaper access to space through new launch services, which are having a dramatic impact on the cost of sending technology and hardware to space. In addition, there's a kind of increasing reliance on smaller low-cost platforms such as CubeSats, which today, despite the fact that they're restricted in terms of size and volume, because of the impact of new digital processes, we're able to do far more on these small platforms than we were ever able to think about doing before. And also there's in general a rethinking of the approach to the manufacturing of satellites, in particular faster design cycles and the use of commercial off-the-shelf technologies. So the end result is that we have a lot of new private capital becoming available to fund many new startups. Because of this new business opportunities, there's a lot of innovation that's coming through, and people are exploring new possibilities in space, from space tourism, new kind of LEO business opportunities, and also you know, the use of these low-cost platforms to do many new tasks. And so who are New Space? Well, I mean, a few of these faces I guess you recognize because they're some of the richest men in the world. And they've been responsible partly for innovating this and getting people excited about new possibilities in space, in particular manned space. So, and behind them, of course, there's a whole kind of landscape of different space kind of industry, from launch vehicles to satellite services to satellite manufacturing, and then of course ground stations and value added services, which gives you a whole kind of landscape of industry behind these big players. So this slide is just to give you a kind of overview of where we think photonics could be interesting. And of course, in payloads, the most probably prevalent ones will be cameras and spectrometers, and also miniaturized LIDARs. Beyond this, we can think of telecom payloads, where laser communication terminals are likely to play a really important function. And of course, there's the whole area of new reusable launchers in space transportation, where fiber optic sensing, fiber optic communication links, and cameras and LIDARs can also be interesting. So I'll just look at a few, we'll just look at a few examples. And I've taken European examples here. Of course, we could have used Planet Labs, or Planet as they're called today, who already have many cameras in space. But this is an example of a European consortium where CERN together with NanoAvionics are combining to put several small satellites or nanosatellites, 16U satellites into space, in order to provide what they call Earth TV. And this is to share the wonderful pictures of space with millions of users on ground. So this of course has so many applications, from disaster monitoring, climate change, all forms of automatic identification services, from finding congestion on roads, or trying to understand shipping problems in like pollution from ships, to services like orbital services in space. So the area is huge, particularly when you think about combining this with other photonic elements like dynamic filtering, and also if you combine it with the thought of how you can use these images together with digital processing and artificial intelligence, the applications are almost limitless. So this is seen as one huge area. Beyond this, we can look at imaging LIDAR, and I took a list of different applications from a paper that was published by Zhao, one of our colleagues, back in 2008. And here we can see there are also a large number of possible applications, from landing spacecraft on other planets, to the navigation and guidance of rovers and robots, rendezvous and docking, you can think of the optical metrology needs of formation flying, and even to things such as space debris removal and orbital servicing. So, you know, this area is also has a huge amount of potential. And of course, I think it's an area where we can think about spin-in from, in particular, UAV technology and also driverless car markets. So this is another area where we could think of huge amounts of potential use of photonics in space. Another area that has received a lot of attention recently is laser communication terminals. And here I focus on the developments of laser communication for CubeSats, because again, new space, we're talking about these small platforms. And I think it's worth mentioning this, this consortium of GOM Space together with TSAT and KSAT, who are producing a small nanosatellite with an optical communication terminal. And of course, KSAT, Kongsberg Satellite Services, are in the process of building the ground stations to provide the necessary communication links to the satellites. But this TSAT development shows what is possible with the current state-of-the-art technology, offering in a fraction of a 1U, so less than 10 centimeters by 10 centimeters by 10 centimeters dimension, weighing 300 grams, they're able to offer 100 megabit downlinks. So this has the potential to open up many applications for CubeSats, because one of the challenges for CubeSats has always been how to download the data. And so this sort of technology can offer a solution. Then we can look at, we were mentioning that in new space, we have, everyone is getting excited about what could be possible in terms of man's return to planets and, to different extraterrestrial bodies such as the moon and beyond. And of course, this means reusable launch vehicles. And here we see also the interesting potential for photonics, because already today there have been several efforts by European and Canadian companies to look at structural health monitoring of vehicles. And here I give two examples with MPB, who have applied structural health monitoring to a re-entry experiment on Rotex, which was one of DLR's re-entry experiments. And of course, I also mentioned Technobis, who've made an integrated version of a fiber Bragg grating interrogator, which they are looking at using for structural health monitoring of aircraft in particular. So, this is a kind of spin-in that could go towards reusable launch vehicles. Here I mentioned Space Rider. This is a reusable vehicle that's being developed by ESA. And currently they're considering having a structural health monitoring system, and fiber optics is one of the technologies under consideration. And clearly I've also provided a small picture of Elon Musk's rockets returning to ground, which, clearly this is showing the reusability aspect. So finally, I'd just like to give mention to integrated photonics. And the reason I'm doing that is because I think that, new space is all about making things smaller and cheaper. And I think this fits really well with what integrated photonics is all about too, which is, this kind of size and weight reduction and increased reliability. I won't even mention the aspects of cost reduction for space, because qualification is a whole nother story, but this could also be of benefit in that area. But the kind of potential areas where microphotonics could play an interesting role, of course, is in imaging LIDAR, and we're seeing several companies looking at using integrated photonics for that. Optical communication transceivers, this is already a trend on ground. But we could imagine it also for space, and QKD transceivers, which are also very complicated if you make them out of discrete components. Spectroscopy, of course, and we could also include, and I mentioned Technobis with the optical sensing for strain and temperature, but you could imagine for manned space missions that chemistry and medicine become important aspects, and there, of course, integration is also an interesting prospect. So with that, I conclude. And just to, I think Jose always asks the question, what can we do for, for you? And I think the answer is that ESA, with its 50 years of spaceflight experience, can offer a lot in terms of what we've understood from our past experience. But in addition to that, I think that we can provide an unbiased assessment of some of your ideas that will not be tainted by commercial interests. In addition, of course, we remain a funding center, and we both initiate new activities, but we also receive many industry-initiated developments. So I suggest that we talk. And with that, thank you. Thank you very much, Jose.
Thank you very much, Iain, for a great presentation. Thank you very much for showing the openness that you have for talking to all the different companies. I would like you to tell me something else. There is, I drove by the European Space Agency this morning, and I saw the incubation center. Could you tell us a little bit of how ESA is helping startups, helping SMEs develop their business in space?
I'll do my best, Jose. I don't know that much about the incubation centers. I mean, maybe Nikos, if you're online, maybe you can help and join in, because possibly you know more about it. Yeah, I mean, these are centers that are established to foster new businesses, and I think basically you get a small grant, and together with that you get some space within the incubation center. And of course, you get access to all the staff, the ESA staff, in terms of help. And beyond that, I'm not too clear about what else is available from the incubation centers. But I know that possibly Eamon and Nikos are online. So if they're able to contribute further information, please speak
No,
up.
but that's enough. I really wanted to hear, because we have around 50 startups in EPIC. I would like them to know that you can go to the ESA website. There is a whole program for incubation on new technologies and a lot of opportunities. And now they have a beautiful building. I just saw it. It's a really beautiful building outside the European Space Agency. If I talk about photonic integrated circuits and I talk about space, I need to talk to my friend Paul van Dijk. We keep talking about this topic. Photonic integrated circuits is a driver for new space because they are smaller and cheaper. But we've been talking about this for already quite certain amount of time. What have you seen lately, not only from Lionis International, but from this whole ecosystem about the introduction of photonic integrated circuits in space, Paul?
Thank you, Jose, for asking. And yes, we've been, I mean, I can talk for Holland. So we are based in Enschede, as you know, so that's 200 kilometers from Noordwijk. So looking at the ecosystem, I think I've been involved with Iain and with Nikos since the last maybe 8 or 10 years, or maybe as Lionis International, even before I joined Lionis International, to help make steps to get integrated photonics matured. And in fact, we have had some projects, and Iain did not mention, but there's multiple programs in the national office, but also through ESA that you can fulfill a tender and a proposal to do an assessment. And it is indeed important, the quality, the qualification, and the whole qualification of the module, not so much of the PIC itself. That is the big challenge. And I think that indeed Technobis was mentioned. They are making steps, and as a Dutch national ecosystems, together with Photon Delta, we are also making steps towards to get more activities there into the development of PICs, also of PIC modules, to qualify it and to have a showcase for the bigger players, for the OEMs, that it's a trustful module that can end up into space. So that's what I've seen.
You know, Paul, once I was having beers with Hans van de Vleckert until quite late at night. Hans van de Vleckert is the CEO, founder, well, not CEO anymore, but the founder of the whole Pantera group. Lion is part of it. And he told me, I love the space market, Jose, because I don't have to worry about the scaling up or ramping up. I make a prototype, and from prototype to product, there is a certain easy path thanks to the whole ecosystem. And he told me always the challenge is the packaging. Is that something that lately we have resolved? Are there steps to help companies like Ommatidia, LIDAR, you're going to hear later about them, to develop packaging solutions that are suitable for space?
Well, this is in fact also a step we took with spinning out or starting Fixed Photonics Assembly as a sister company of us 3 years ago, to focus on packaging, to focus on new standards, and to ramp up for volume assembly. Because indeed, as you say, assembly is a big part of the solution. And you can have a PIC that performs, but if a wire bond breaks, or if something breaks in a shock test or radiation or something, that is annoying. So it must the whole manufacturing process must be qualified. That's the important.
It's funny that I mentioned packaging. I already seen the YouTube channel, Greg Flynn from FICONTech and Bernd Grief from aXenic talking about that they already have solutions for helping companies in the automation or the packaging that doesn't really require large volumes to be actually useful. I want to go to my friend Bob. Bob Musk from Entropics. You've been working with different packaging approaches for photonic integrated circuits for many, many years. For the space market, what have you seen special in the last years? And are we going in the right direction towards bringing packaged photonic devices into the market?
Yeah, it's interesting because space qualification, as Iain mentioned, is one of the biggest challenges. And always there was a ban on epoxies or organic materials. They seem to be softening a bit now, so long as you can qualify. Is that right, Iain? I think you need to unmute.
Yeah, we have you muted. Yes.
Yeah, I think that's true, that we're softening a lot of stances, from hermetic sealing to the use of epoxies. I think there's a kind of new pragmatism about what can work, and particularly for new space where maybe lifetimes are shorter, then there may be new solutions available.
Yeah, and I think the other thing, and I'm sure it's going to come up, is about radiation hardening and testing. That's another tricky one to get over. And I think with the new PICs, that's a difficult area to work with at the moment.
We've done quite a lot of testing of, we've done some testing of PICs, and in fact, if you look at the radiation effects on PICs, then quite often the thermal effects can be actually more challenging than radiation effects, because they're very, they can have similar effects, but the magnitudes are much bigger in terms of thermal.
Yeah, okay.
We have a question from a newcomer to this community, Lidax. Thank you very much for joining today. What's your question?
Do you hear me?
Yes, loud and clear.
Perfect. I was wondering if Iain can tell us if there is any database managed by ESA about any photonic component suppliers that could be already qualified for space. I know that there is another initiatives on this sense. Could you please give us some advice for having this kind of already qualified suppliers?
I can answer that very quickly, because we basically have virtually no qualified parts in photonics. I think the only qualified part that we have, maybe two parts. One is optocoupler, and the other one is a fiber optic connector. So basically, and this continues to be the case, we continue to use commercial off-the-shelf products in general. Of course, there are preferred suppliers, and we can talk about that, but I think that one of the things that we're learning is that with the use of COTS, that we have to be open to new new ideas and new ways. And so sometimes we fall into the trap of using products that we've used in the past where there are perfectly good alternatives out there, but we just haven't had the experience of using them. So it's something that is a bit tricky to deal with. Does that answer your question?
Yes, it did. Jesus, it's your first ever EPIC meeting, so you need to tell us what LIDARs do and what the others can do for you.
Well, let's say that we are in partnership with Beamagine for developing a LIDAR for in servicing operations. And that's why one of our major concerns is about the electronic components that could be useful for this type of space devices. And that was the main origin or the main source of my question.
Fantastic. We're going to discuss this later, but I have another question from Enrico from Eventech. Thank you very much for joining today. What is your question? I have you muted, so I need to unmute you first.
Okay,
Yes.
that's it. Okay, first of all, Iain, thanks for the nice overview. You talked about what can do new space, what are the domain of new space, but you did not touch what the new space cannot do. And I think a number of applications cannot be done with the new space. In particular, I refer again to, for example, you mentioned LIDAR, imaging LIDAR. Okay, the imaging LIDAR, if you want to do on new space, as you can do on drone. On new space, the performance system requirement will not be compatible with a new space requirement. If we take, CubeSat, we have, as you know, at ESA, we have now the Daedalus is the next Earth explorer, which is being understood. And as a matter of fact, it is a CubeSat mission which has been selected. They are multi-cube, but if you see the instrumentation on board, the technology that is used is rather conventional, and these ones are rather, I would say, off the shelf. So the new space, I think we need to clarify that new space cannot do everything. New space can definitely tourism, can extend some application that now we do on drone, but not much more because the performance, the orbit, the system performance requirements are limited for in this concept. So I mean, this was the comment I wanted to make, that we should not be impressed by new space. We can do everything. No, we cannot do everything with new space. We can do very limited things that we can do now with CubeSat, with drone. We can do a bit more than drone, but we still need to work on mutualization of technology, restructuring of resources, interfaces, and qualification. And of course, new space, another issue that will be posed is lifetime. Because lifetime will require a lot of effort.
Yeah, and I fully agree with that. I think we have a comment from Ommatidia, who is one of the companies who have struggled with everything that you are saying right now.
I mean, I have a presentation after, so probably that will make sense. But I think one of the main comments from Iain was actually making the thing compact, right? So LIDAR in space, I would say it's possible as long as the solution is compact. And what we try to do at Ommatidia is actually to make a compact solution, compact LIDAR. So probably making it possible to integrate into a CubeSat type.
For what applications?
Well, actually, we are starting a project next week with ESA on measuring large antennas. So we have, so they are deployable antennas. I think that's one of the topics that Iain mentioned. There is no real, I mean, there are ways to reshape the antenna. So they know how to modify the antenna based on, I mean, knowing how the antenna moved, but then they need to have the information how this antenna has been reshaped or been modified in space. So that's metrology-based system. That's what we aim at. But Iain mentioned a long list of applications, and I think I need to talk to Iain at some point.
Gregory is going to make a presentation later, but I have a question from Sandesh from Trust Celestial, perhaps the most beautiful company name I've ever seen. What's your question?
Yeah, can you hear me?
Yes, loud and clear.
Okay, great. So yeah, I'm an optical designer from Trans Celestial Technologies. So how are you gonna achieve like coupling into single mode fiber from in space application? So if you use something like off-axis parabolic telescope, so what are the methods you imply to achieve fiber coupling? Am I clear?
Fantastic question. Very, very tough question. At the end of the day, the attendue effect is going to be always a limiting factor. I think, Iain, would you like to talk a little bit about this? Because otherwise, I would like to leave this open because this is one of the biggest challenges we have had in the past, especially when Iain was presenting photonic integrated circuits for spectroscopy.
Can you repeat the question? Sorry, I think I missed it.
How do you couple light from space into a single mode fiber?
Exactly. There are some applications now. The company name called Cailabs from French. So from France, they come up with a solution. So like ISA is like delving into any other new concepts to sort this problem. I think this is a big major bottleneck in optical domain, I would say.
We do have Cailabs in the room, actually. David, how are you doing?
Hi, fine, you?
Fine, great. I think you're going to have a presentation later, so we're going to discuss this.
Yeah.
So I would like to, first of all, thank Iain, because you guys, you're fantastic. You are really, truly fantastic. You're a hero for space in the EPIC community. And then go to one of the companies who have impressed me the most in the recent years. From New York, PLX is a company that you ever had the chance to see the coolest retroreflector ever. See what they can do. Itai, thank you very much for being with us this afternoon. Tell us how we can help you and how you can help us. The floor and the attention of everyone is yours.
Good morning here from New York. Tell me just if you hear me. Do you hear me? Well, okay, good. Good afternoon to the colleagues in Europe. Thank you so much for inviting me, Jose. Always a pleasure to see you and collaborate with EPIC. You're doing a great job, specifically these days. Without further ado, I'll just start my presentation because I just have 6 minutes, if I'm not mistaken, Jose. My name is Itai Vishnia. I'm from PLX. We are in Long Island, New York. As the first slide emphasized, we are transforming space optics by integrating innovative monolithic optical system. A nice sentence, but in general, what we are specializing is light manipulation, the art of light manipulation in extremely high accuracy and harsh environments. So needless to say, space arena is one of our main presentation. We participate with many large space programs, but more so right now we see the interest of nanosats and LIDAR, whether it's space on ground, but these are where you can find our parts. So in general, light manipulation, how do we do this? Sub-arc second, through sub-arc second beam delivery system, beam folding and steering, and as well as spectroscopy in space, and all that under harsh environment. All of this beam shaping and folding is being done with a specific technology, which I'll introduce in a second. I just kind of want to emphasize, and that's strictly related to the EPIC arena and the friendly approach. This is essentially our business model, following EPIC approach, looking for constantly partnership of talent companies, small to large. We accustomed to work with both, and adding to our capabilities and work together. We do have, we do have significant space heritage, which I'll introduce in a second. But when you push the limit, you really want to look for good partners. So talking about business model, we're dealing with optical assemblies through sub-integration and system integration, and you can see the following categories. In terms of what we've achieved, we go as low as 0.2 arc second. We are dealing with hollow optics, so as such, we are not limited with the spectral arena. We can cover the entire spectrum. dealing with really harsh environment. You can see just an example of some shock and vibration that we've dealt with, but each one is really specific to the application. Some flavor as far as our space heritage. These are just the major programs that we dealt with. As you can see very clearly here, there is no specific CubeSat program. These are all small companies that we are not listed here, but through EPIC, thank you for the previous new space presentation that we've had. We actually collaborated already with a couple of companies, and right now things are kind of on hold till we open the economy and we can move forward. So we do have some exciting news as far as where we can fit in. CubeSat and free space optics are the biggest. And Jose, this is exactly what you like, what we can provide and what we need. I'll just summarize it here now quickly, and then I'll move to the next slide showing our technology. So miniaturization is what we do best with conventional, unconventional optics, whether it's freeform optics, whether it's conventional optics, integrating it together into a small CubeSat where cost is really an issue, and you don't have the voltage energy to warm parts, and you really need them to be accurate. That's where you can find our technology. For simple application, PLX can supply standard cuts. But the integration aspect is really where we can support the CubeSat, nanosat arena. In terms of free space optics, ground to satellite, inter-satellite links. When it comes to triangulation, there is a lot of cost saving associated with that, not just communication. Triangulation with retroreflector is easy done because the beam is reflected back to its source. This is just an example of some of the project that we participated in. This is a retroreflector combined of 3 silicon mirrors. One of them is MEMS. I'll jump quickly to introduce the technology, monolithic optical structure technology, with this short video. What you can see here is a lab setup of a Michelson interferometer. So spectroscopy in space is something that we've done quite a lot. This is the conventional approach, very sophisticated. Mechanical design can always be done, but the big challenge is how do you have it maintain its accuracy. Sub-arc second accuracy in space is meaningful because of the distance. So this is what I call the plug and play approach. You replace the very convoluted, very complex design, save significant amount of space, insert a block which is very rugged and integrated to the next level assembly properly, pre-aligned, and you achieve very high accuracy. So that can be scaled up significantly, scaled down significantly for the CubeSat. We've made parts that are like 2 millimeter in size, even assembly that are like 10 by 10 millimeters. We are definitely looking to stretch the limit, and I'll go back to this previous slide in terms of partners and where we can get some help and support. We are constantly investing in developing new material. We are trying to work with the existing materials that we have available to us, but we are definitely looking for partners that can push the limits together with us in lightweight materials that essentially are one, both for structural as well as for optical. So materials that can be polished, materials that can be used for structures and combined using the most technologies that I presented here. This is, again, just to give you a flavor of the type of accuracies. The thermal dependency of this particular assembly that you see here is 0.115% per degree. Jose, do I have another minute or two, or no? So-and-so. Okay. Quickly, just to explain how this technology is put together. Monolithic structures, invariant optics. So the invariant optics is the most important thing. Invariant optics is obviously based on hollow retroreflector. We are the pioneer of hollow retroreflector, and when you have hollow retroreflector inserted in the proper orientation, or in general, you build the monolithic assembly with the invariant approach in mind, then you can achieve the plug-and-play approach. You can see an example of lightweight optics in terms of the aerospace arena. Just some of the projects that we've participated. Tropospheric emission spectroscoper. This was a mission of 14 years, 2004 to 18. We put together all of the components and assemblies for the interferometer, for the FTIR spectrometer. All were made with beryllium, 1 arc-second inaccuracy back then. This is Tirvim with ESA. This is the Mars mission. This is still working, functioning. This is the retroreflector that we're inserted in the system. And currently we do have a LIDAR system, big LIDAR system, but can be scaled down. That this shows a telescope alignment. This is with the Atlas program. It's ISET-2, measuring ice sheets. I think that I'm done with my presentation. I'm just going to show you when you ask if you have any questions, just some. I see
Thank
that you
you.
cut me off. But
Thank you so
thank
much.
you.
It's always nice to hear again. Of course, miniaturization is one of the main goals for this new space technologies and lighter, of course, and low power consumption. All this we will go through it today. So you know how it goes with EPIC. So now you show us what you can do for them, and we need to know. So you show us what you can do, and we need to know what can they do for you, or what kind of collaboration are you open to?
Yeah, if I can share again my screen, I'll just go to that slide and we'll just
sure.
What we are looking again is as far as what we can get from both from ESA is very clear guideline of the application and the specification that they want to achieve, because we cover pretty much everything, whether it's with ESA, whether it's with NASA. So that would be one ask from the entire community, really pushing and trying to stretch the limit with lightweight materials. So there are a lot of methods that we invented here with lightweight optics, but we're definitely looking for more collaboration from the industry. We are talking about materials that are going to be user-friendly for cryogenic environment, material that would be user-friendly for optical performance. So I can give some ideas. Silicon carbide is considered to be old. We're looking for something that would be able to polish like aluminum, light, and yet integrate together with the monolithic optical structure technology.
Very nice. Do we have a question from the audience? Or a comment? But at least now we know what kind of collaborations you are open for, and I would like actually to go to our next speaker from Belgium, Hakimeh Mohammad Hosseini.
Yes.
Hello.
Hello.
It's so nice that you join us today again.
Yeah,
we saw you in the microwave meeting, and we'll be very happy to hear your talk today. Maybe about SATCOM, satellite communications. So this will be also interesting for Itai, I guess. Please start.
Okay, thank you.
Thank you.
Good afternoon, everyone, and thank you for the kind introduction. I will try to share my screen with you. Okay, is it clear?
Super clear.
Okay, no problem of 2 monitors this time, Jose. Okay, so today I'm going to present you Antwerp Space recent activities in the field of satellite communication and also photonics, since we are leveraging photonic integration technology for providing new and improved equipments for space and for satellite communication. Antwerp Space roots get back to 1962, where we were part of Alcatel Bell Labs. From 2010, we joined OHB Group, and from 2015, we have started our photonic activities. So here I would like to share with you Antwerp Space recent achievements in the field of space communication and satellite communication. Our main focus is to design, to integrate and deliver complex communication subsystems for ESA science and exploration missions. So some examples here, for example, on top left, you can see JUICE communication subsystem or Jupiter Icy Moon Explorer, which is the first European mission to explore JUICE and its icy moons. And will communicate with Earth with X and Ka frequency bands. Another example is LARA instrument on the bottom left, which is a very compact radio science coherent transponder instrument to land on Mars surface, and it's part of ExoMars 2020 mission. And this equipment also will communicate in X-band frequency and will study inner layers of Mars and measure how it orients or how it rotates. Also, very recently, we launched the Argo modem, which is a very integrated software-defined radio modem. And you can see on the bottom right of this picture. And it happened recently on February 2020, and we launched this to International International Space Station. It will triple the download capacity of ISS. And about the photonics, in 2015, we have started our photonic activities. Here you can see a photonic integrated circuit chip. And the rationale why we started with photonic actually lies behind this picture, JUICE communication subsystem. You can see a lot of bands, waveguides, and switches in such a subsystem, where you can actually implement many functionalities here with photonic technology, more specifically with photonic integrated circuits. Or you can use fiber optics inside the satellite to transport signals. So in that sense, it is very useful to use photonic in this subsystem. And to make it more quantitative, if you want to transport 1 kilogram of mass to Jupiter, it will cost you 30 million euros. But if you want to do the same to Moon, it will cost only 1 million euro. That is why it makes a lot of sense to use photonic and photonic integration technology for such missions. So Antwerp Space, Antwerp Space uses of photonics in a spaceborne application can be divided to 4 different applications now and in future. It could be satellite beam steering antennas, radar instrument front ends, or a core element of laser communication terminals, where we try to develop photonic integrated solution to implement core elements of laser communication terminal. The same here for a flexible telecommunication payload. Many functionalities here could be replaced with the photonic technology. It could be a frequency generation unit, a frequency conversion unit, switching parts, etc. So more specific, Antwerp Space current activities for users of photonic integration technology can be divided to 3 different projects. Currently, we are working on frequency down converter. You can see here on top left, a space beam on the right side of the picture, and also photonic lantern. For EPFC, it is a QV band frequency down converter that the duration is 3 years and the TRL level is 5 to 6. Here we get 47 to 50 gigahertz signal at the RF input and down converted to 17 to 20 gigahertz at IF output. You can see the tiny photonic integrated circuit in the middle. RF front end and also control electronic board are around. This project is funded by ESA. In our other project, the space beam, we do photonic beamforming for radar receiver application. where we have 12 antenna elements, and we down convert and beamform signals in the frequency range of 5 to 40 gigahertz down to 1.5 gigahertz. The TRL level is 5 to 6 years, funded by EU. Here also you can see the photonic integrated circuit, RF front end, and also control electronic around. Also, another interesting project is the photonic lantern receiver. Here we try to develop photonic integration technology to implement the fine steering mirror inside the laser communication terminal. The duration is 1.5 years roughly, and the TRL level is 3, funded by ESA. Here we use photonic integration technology to implement this fine steering mirror with a very powerful integrated and multifunctional solution. So the most important part for this meeting, what we can do for you and what you can do for us. Antwerp Space can be an equipment integrator. We can generate requirements for the peaks for space application and also design microwave links. We have heritage in control electronics and RF front end. We would like to collaborate with you for a space qualification, like we look for partners for space qualified components, and also end users, either satellite or payload integrators in the space sector and for the targeted application uses. In doing all this, we are not alone. Antwerp Space work and talk with many partners daily for either for peak fabrication or for packaging or for designing with design houses. So thank you all of these partners. And I would like to thank you. And please let me know if you have any question. You can always contact me or Stefan, our business development manager at Antwerp Space. Thank you.
Thank you so much, Hakimeh. You see that slide with all the companies that they work with? All of them are members of EPIC. Thank you very much for that. That was really fantastic. A great present to start the weekend. I have a couple of things I want to do. The first one is I want to introduce you to a very dear friend of mine. Antonello Banucci comes today with a new company, Photonics 42, and we are all very curious. What does Photonics 42 do?
Okay, so thank you, Josep, for this kind introduction. This is a startup. Now we are working on inside with a strong partnership with Politecnico Milan and with all the photonics teams of Politecnico. Our main activities related to photonics packaging. So this is what we did in the past in my former company in Corton. Now we are trying to do more dedicated activities on photonics for space. For example, this is one of the targets that we would like to achieve in the next year, in the next years. And the other products that we plan to develop is together our strong partner for equipment manufacturer is testing solutions for photonics integrated circuits. This is strictly related to the buffer level or buffer level packaging or buffer level testing.
Excellent news, because as I said in previous meetings, we need more packaging companies focusing on niche markets, and you seem to be looking a little bit at the space one, which is very interesting. Hakimeh, you keep asking about different packaging solutions for different technologies, from transceiver to anything that has to do with photonic integrated circuits. Could you give a challenge to Antonello in the sense of packaging of PICs?
One challenge could be, of course, for this kind of application to put RF front end together with the PIC in the same package. So this is very important and useful for many applications to reduce the cost and also the losses.
Okay, so this is, you are speaking about system in package, RF system in package, a microwave photonics system in package. This is one of the key activity that we already discussed in the past when I was in Corton. And for sure, this is a very challenging about thermal aspect and thermal management inside the small package that is required by this application for space application. For sure, for a transmitter is could be very challenge. From other side, from receiver side, we have to manage lower power dissipation and could be more affordable than from transmitter side. But by the way, so I think that is with the right materials and dedicated development in terms of we can provide a solution, the right solution for this development phase of the new based components and modules.
Excellent, Antonello. Any questions, comments for Antwerp Space? Because there's a company that I really want you to meet because I'm very happy they're here. It's a company called Amphenol. Many of you know them because they are really bringing electronics to many different markets, from military to aerospace. We have Gregory with us. Gregory, why did you join this meeting and what kind of cooperations would you like to do with these people?
Hello, Jose. Can you hear me?
Loud and clear.
Thank you very much for hosting first. So yes, I'm from Amphenol, so it's an international global company. I'm in the aerospace and military operation, and for sure we are active in connectics, so connectors, harness, and so on. There are actually 2 qualified fiber optic connectors, but I'm more interested in the transceiver business. Because a part of the Amphenol company is in telecom, and we are packaging transceivers, let's say 24 channel, 25 gigabit per second transceivers for now also aerospace application, and we are looking to see the opportunities in space maybe, and maybe potential for qualification. So I'm a bit curious about the space of photonics and new space, of course, to see whether there's a good opportunity to go with our packaging and try to qualify it for space. That's it.
Excellent. It is great that you're looking at the transceiver market. We do have great companies developing integrated photonics for transceivers today. They are entering little by little this segment. I think later we're going to hear also from our friends from Switzerland, from Ligentech. I think it's time to continue. By the way, Gregory, are you looking for LIDAR as well? Because I saw in your website there is some activities on LIDAR.
Not specifically. So
but you're going to hear about it anyway, because the next presenter is Ommatidia LIDAR. It's one of the coolest companies I have seen lately, because they are in stealth mode. They cannot share much. But whatever they can share, what's important is what can we do for you? Or what can you do for us? Thank you very much, Greg, for being with us this afternoon. The floor and the attention of everyone is yours.
Thanks, Jose. Hang on, so I'll try to share my screen. Yes, I think it works. It works, right?
Yes, go presentation mode.
Great, here we go.
Yes.
All right, thanks, Jose, for the introduction. Thanks, actually, Iain, earlier on to introduce LIDAR and actually to introduce the possibility of LIDAR actually in space. Because when I refer to this talk, I mean, one of the key aspects was actually compactness, achieving compact LIDAR. So what we do, so we develop integrated solid states, fully solid state solution. We use flood illumination. We do all digital imaging, and this is thanks to being able to read out actually a huge number of optical throughput. So why we do so is because we take actually our name, but also our application is based on what you can see here on the screen. So this is a fly, actually specifically a dragonfly. And this is one of the best optical LIDAR you can find on Earth, right? So how does it work? You have actually 40, so the fly has actually on each eye actually 40 Ommatidium, right? And therefore our name. And each of these 40,000 Ommatidium, and each of these Ommatidium actually relates to 8 detectors, right? Which gives you a number of 320,000 elements. thanks to that, yeah, potentially you have a wonderful imaging system, and you can also track direction, right, nicely. So what we try to do at a much lower level is try to mimic nature, and not on the chip that you see on the left, but on the coming chips. So we are trying also to design something which is extremely similar. So we have 12,000 waveguides that will be reading the scene, attached to for each of them attached to 4 detectors, so which should be close to what the dragonfly does. Further, we also use coherent detection, which allows us to do video rate imaging. So we have really fast data acquisition on the cloud. Further, because we use flood elimination, we are also able to aim at longer distance, which is not necessarily needed for space, but still, if we look at beyond like automotive market, I mean, that's still one of the key requirements. So how the solution looks like, and because we are looking at really something which is compact, right? So it's purely solid state. So it's a chip, so it's a PIC. So in this case, it's a very simple PIC. So there is no 12K output waveguides. We are limited here to 120 waveguides, but this is just a proof of concept. So so the light comes back from the scene. So we illuminate the scene, the lights come back from the scene, and we actually read out the information. So the detector plays a bit further down the chip, and we read out the information here at the middle of the chip. So where are we? We are TRL4. So this is actually a chip that we tested heavily by the end of 2019. And what we aim at being, is in TRL6 by the end of 2020. What does it mean? That means, but I will come back to this later on when I talk about looking for partnerships. So what does it mean? That means being able to have on the platform a huge number of waveguides, while being able to read these waveguides, either in a hybrid form or in integrated form, like detectors on the chip themselves. So we are publicly funded with some shareholders. And besides, we also, next week, or 2 weeks from now, NASA project starting using our solution for metrology. So what we offer? So what we offer actually is what we believe is a unique solution. So briefly, I mean, the LIDAR market is divided in two main ways of doing LIDAR. So one is the time of flight, where you send a pulse and you collect it back, with the problem of having the information delayed when it comes back, or what is believed to be the future, which is the FMCW approach. In both cases, what people do is actually steer the beam, and therefore that means that the acquiring an image is actually pretty slow, because for each point, basically, you have to steer. And that can be done actually mechanically, and this is what the next presentation will be about. Or you can also do it on chip, and this is what people try to do with OPAs or MEMS at a smaller scale. However, on our side, we use FMCW while flooding the scene, right, which allows us actually to go much beyond in terms of distance. And therefore, with this, we believe that our positioning is pretty unique. And because we aim at very compact solutions, so we have attracted some interest from ESA in measuring actually large deployable system. Large deployable system. So what we aim at doing, so of course it's not in space, because we don't aim at qualifying the system yet for space. We'll do the experiment on ground. So we'll load the antenna. I mean, we hang the antenna on mechanical support, and we'll measure on the floor, right? So here the challenge is not necessarily reaching far, I mean, like the automotive will need, like the 300 meters, but instead it's actually the resolution. So it's like being able to resolve on the reflector, which are actually full of small metallic particles that will reflect the information, being able to resolve down to 1 micron. So that's going to be the challenge for us, but thanks hopefully to the large number of waveguides that's present on the solution, we should be able to do so. And of course, also achieve the the depth, because the antenna is not flat, so it's not a flat surface, but it's a curved surface. So what we are looking for, actually, we are looking for, especially nowadays, because now we have actually systems that are getting packaged in 20, so in fixed. I think we mentioned some. I think Linux mentioned fixed at some point. So we are packaging some of our solutions now at fixed. But once we have the solution, then we need some use cases, right? So we have been attacking. So far we focus ourselves in metrology, but I mean, based on what Iain said about applications in space, I think we can go beyond metrology, and still limiting ourselves to metrology application. I think we have also attracted some interest in trains. So not only to look at the railways, I mean the rails actually, but also the surrounding areas. So like what's happening on the front, if there's anyone standing in front of the train, also around, so if there's any trees obstructing the way. And further, yeah, we still aim at scaling up the technology. So that means being able to bring these detectors on the chip while having still a large number of optical throughputs. So that was my 3 slides, because I was limited in 3 slides, so I didn't know exactly how much.
It was very good. Thank you so much for the very nice presentation. When I see LIDARs and Earth observation, it always come to me the Green Deal from ESA. Can this be part of the new space in? This is my question to you.
To me or to Iain?
To Iain, sorry.
Yeah, okay, yeah, because I would not be able to.
I just want to know if your LIDARs can be used in the Green Deal as well.
I think that that these type of LIDARs are probably more useful in the short range.
Yeah, so yeah, if I may comment, so actually what we aim at doing, so I mean for the current project on measuring the antennas, right? So the short range is, I mean the range is not needed. However, our solution can aim at 300 millimeter easily. So we are not necessarily limited in well, unless you mean short range, unless 300 meters is short range. I don't know.
Well, I mean, like as opposed to Earth observation, where you want to, you know, do LEO LIDAR or something like that, which would require much larger range.
Yeah, but I mean, if we look at what Allioux does, then it's actually going down to a different wavelength range, right? Where you have actually much more power. So that could also be considered. I mean, we are wavelengths agnostic, so we never look into UV. But if there is any platform that allows us to do UV, I would say why not? But this is more a question for Linux, for example, if they would be able to work in this wavelength range.
What do you think, Paul?
Okay, yes. Well, I made a picture here behind me. You can see what type of wavelength we can cover. So it is from blue till 2.5 microns. So we talked about it, Gregory. So yes, that's our platform.
Good. Yeah. So I don't know about Iain, but I mean, yeah, typically in our case, our solution can be modulated. I mean, it's once again, it's not wavelengths dependent. You can apply it to any wavelengths. I mean, that would still mean designing the chips in that wavelength, which is a different story. But if there is a platform that allows UV, yeah, we can think of scaling down also I mean, what Allioux has been doing so far, right? Like looking at clouds, looking at because what Allioux does is just get a Doppler feedback from the cloud, right? To my understanding, but that could also be done at smaller scale.
Greg, let me introduce you to someone. We have a newcomer today to this meeting from Odysseus, which is a space company who had developed many projects on spacecraft navigation. Why did Odysseus join this meeting today, and what kind of cooperations would you like to make with these people?
Hello, everyone. Actually, we are developing two technologies right now. We are based in Luxembourg at the moment, in Luxembourg and Taiwan. And here we are working on a laser communication terminal for small satellites with both inter-satellite link and down-to-earth capability. and autonomous navigation. So the reason today was to of course there are some companies I know already, but to get to know a bit more companies and maybe some possible suppliers or partnership. Right now we are still in a quite early stage of development of our terminal. It's the TRL4. So we are still looking for some specific parts and some solutions.
Thank you so much for the introduction. So we are now halfway with the talks. We are within our next talk, also for imaging LIDAR for space. We have Beamagine, Santiago. Yeah, we can hear you now.
Okay.
So
Great.
we tried the sharing. You can just share again.
Okay, let's see what happens.
It's gonna work, don't worry.
Share. Does it work?
Yes, it works. Perfect.
Perfect. Okay. Well, as we were commenting, we are Beamagine. We are a LIDAR company working around Barcelona, and we essentially are manufacturing currently a solution for LIDAR, which is based on a technology we've developed in the past, which is different and which has some advantages and disadvantages related to the one that we have just seen. For our case, what we have is a technology which is now patent, where we are essentially able to provide very, very large solid state imaging by scanning with a MEMS mirror, which is solid state for automotive, which is the field with which mostly have been working. The system works in real time. We can have 10 frames per second. You can see videos in that web page if you want, because I mean, we don't have much time in the time we have available to show videos that you have there uploaded, so you can take a look. And currently we are managing especially to have very, very high resolution, which means having a lot of details in what we are measuring, being able to get ranges which of course depend on reflectance, but can be something about 150 meters at very low reflectances. As far as we were working in automotive, we found out that people were not really looking for LIDAR, or were also looking for LIDAR and video images combined with LIDAR. So we managed to twinkle a bit our technology, so we were able to perform data fusion free of parallax error in real time. And now you may see that the images that you see here are, you have up right the RGB image, and down you have the range image from the LIDAR with the level of detail that we are mentioning. Then we have range and reflectance, and we are able to fuse the image with RGB images seamlessly. So in each point you have the RGB information and the depth and the reflectance information. If you move forward with an RGB camera, but you can do that with any other camera, so you can do it in RGB, near infrared, shortwave infrared, you can do it in thermal, and you can even do that with polarimetric imaging. For the moment, the record is fitting 12 imaging modes in a 10 by 20 by 20 centimeters box without any optimization in size. So we have not been in applications where for the moment have been requirements on size. If we start with custom optics, everything in this system is completely cut, so we can manage to have very much smaller systems if we need it. Regarding space, some 1 or 2 years ago in collaboration with Thales Alenia Space. I'm not going to enter in depth in the applications because the applications they were targeting are essentially the applications that have been commented by Iain before. But for them, we were starting one of the things that have been more useful to us in the past, which is the ability to tailor the units for given applications. So we are, in that case, for instance, we were doing LIDARs for automotive. They didn't need the level of frame rate we were using in automotive, but instead they preferred to have very larger spatial resolutions. So we moved forward in order to develop a system which was tailored for that applications. And we managed to get this type of incredibly high density point cloud. It's 0.005 degrees in the point cloud with range and reflectance images. That's a system which is working, which was tested inside of the project in ground for Thales Alenia, and well, we've kept contact with them and we've moved forward because of course, that's something we did on ground. So in collaboration with LIDAR, with Jesus, who was before speaking here, with launching a new GSDP project with ESA, which is starting right now, which is approved, and which is going to develop a specialized LIDAR for in the coming weeks or in the coming months. We call it smartly 3. We need to manage maybe the name afterwards, but at least we have a number, a name for the moment. But the goal is to develop 100% space functional imaging LIDAR. And if you want to hear what we are looking for here is that we in fact have an open call to receive the space LIDAR application that's more interesting to you in this kind of environment, because we are going to develop an engineering model anyway. So we can try to build a space LIDAR application which is especially suited to the application or to the type of whatever, or the application, the service, or the type of vehicle that you may suggest. So we can design or monitor that in any size, and we will build an engineering model tailored exactly to your application. We have an open model. You can contact me, and we will continue the discussion from that point. The same thing I can say about the rest of the presentation. This is something 6 minutes gives not much time to discuss things. We are doing things in different industries. If you want more information on LIDARs, just send me an email or call me. This should be, or this would be the typical applications we have in a unit. This would be something which is quite a custom idea. But of course, the nice thing is that we're building LIDARs for 3 or 4 years, so we are able to tune the application and to look which are the right trade-offs for the type of application you want. You can have larger spatial resolution, you can have smaller frame rate, or whatever, you have to pay prices, but you can get to a very good balance in many senses. And in special regarding the imaging modes that we mentioned before, if we want to add imaging modes, that's pretty easily without many more things to say. As far as typically people is very concerned with range when they speak of LIDARs, and that's partly a mistake because people should concern about range, but should concern about spatial resolution. We prepared a short simulation of which are the types of ranges that we can have in a given configuration in our system. We prepared a typical configuration, which is that one you have up at left. And we compare which type of range could you get with in darkness, in complete darkness, and with 2 types of sun simulators, a sun simulator from Arrimax and an halogen lamp, and that in indirect illumination and indirect illumination, you may see it here. And it gets out that if your reflectance is 80%, well, you can choose still which is the level of eye safety that you may need in space, but you can be class 1, you can be class 3R, or even you can be class 3B. And then you can see which are the ranges that you're about to reach in these conditions. It's only an example illustrative of the type of solutions that we can provide. Again, for your time, if any of you is coming to Second 2020 in Korea or to IFSEC in London, we will be very glad to comment these things in person. Thank you very much for the opportunity, Jose and Sana, and waiting for your comments and your contacts.
Thank you very much, Santi. This is really the new space. This is a company, Beamagine, that was designed to make LIDAR for automotive, and they are bringing the concept to space. This is why new space was created, so we'd like to congratulate you on this. And we have a question from Enrico from Eventech. I think we have you muted. Let me unmute you. I think you need to help me on that to unmute yourself so we can hear you.
Yeah, sorry. Yeah, interesting paper. Congratulations of the nice work. I have a couple of questions for you. First of all, I mean, what type of transmitter do you have? What type of technology operating? UV, visible, infrared?
It's infrared currently. We have 2 systems, one working at 1064, one other working at 1.5 microns.
That's 1064, CO2?
One at 1.64.
Okay,
Another one at 1.5 microns. We can more or less select the wavelength. I mean, it's about adapting the design on the top.
Okay, and the focal plane, what type of detector do you have?
I don't want to get into many details, but for this case, I can say it's an avalanche photodiode.
Okay, but I mean, if you have imaging LiDAR, so how do you image this 50 by 50 degree field of view?
By scanning, we scan. We have a number. We scan, but we scan with a MEMS mirror, which is suited for automotive, so it's expected to stand. And that's why we are working with LIDAR currently to improve the system, the durability for launching, and the mechanics for the system, so it can survive the space environments.
Scan for space is not a good idea in general. It's not a good idea. You should more consider to have a 2D array.
It's a 2D MEMS mirror.
You need a 2D array, yeah. I mean, MEMS are not very good, I mean, MEMS are not very good. You have a 2D array.
On the ground, they work. For the moment, on ground, they work. It can be better, of course. Everything has trade-offs.
Well,
everything has advantages and disadvantages.
I'm a huge fan of MEMS myself. There is a company that I want the two of you to meet. It's the first time they come to an EPIC meeting. It's called Space Optics. Thank you very much for joining us today, Matthias. What did you come to this meeting, and what kind of connections can we make for you?
Hi, Jose. So we are quite new. So we are a startup. So we're just founded 2 months ago, but we're coming in with, let's say, quite a long heritage. So we are a spin-off from the Fraunhofer Institute for Applied Optics and Precision Engineering in Jena. And we are focusing on developing and engineering metal optics for space. So we are a component supplier and subsystem supplier. So making especially freeform optics, and very compact ones in metallic materials for laser communication, Earth observation.
Freeform metal optics.
Freeform
metal optics. Is there any current activity in space that uses freeform metal optics?
Yeah, well, so within the time and so we have a kind of a, let's say, 20 years heritage in Fraunhofer. So there are systems already flying, for example, the Moderators instrument on Baby Colombo, or there's a hyperspectral imager called DESIS on the International Space Station. So they're all using this kind of metal optical technologies. And what makes it so interesting for new space is because you can make it very compact, you can make it very fast and, let's say, comparable cheap to silicon carbide optics, for example. And you can produce them quite in high volume. So that's why it's making so interesting, I guess.
What kind of supply chain challenges do you have? Looking for coatings, looking for validation, looking for design partners? If you could come up with a great partnership today, which one would it be?
So first of all, we just wanted to say hi, we're here.
Hi.
Yeah, we were looking for all kind of partners, of course, for customers who are interested in mirror optics, but also maybe for companies who can help us with design work, or also for coatings, for example. So.
To be fairly honest with you, I'm amazed of metal optics. I'm a huge fan. I went to Aachen and I met a company called Sonex, and they show me what they can do, and it's truly fascinating. So Benjamin is here with us and he speaks fluent Spanish, so that's why I like him especially. Benjamin, muchas gracias por estar aquí. Thank you very much for being with us this afternoon, all the way from Aachen. Tell us what Sonex can do in the field of metal optics. The floor is yours.
Thank you, Jose. Good afternoon, everybody. I'm very happy to be here and to be able to speak to you. Thank you, all of you, for being here this time of the day, especially on a Friday. I'm managing director and one of the founders of the company Sonex. I'd like to briefly introduce to you the company itself, and then quickly go into what we do and what we can do for you. So we are also a spin-off from a Fraunhofer Institute. You can see that Fraunhofer is quite successful in Germany, spinning off companies. We were founded in the year 2011 here in Aachen. We are now outside of the Institute. We have our own building and our own manufacturing and production environment. We have two business fields that we are working on. One is ultrasonic manufacturing systems, which is not straight related to this topic today. And on the other side, we do ultra precision machining. Sonex is a pure optics manufacturing company. We do manufacture optical mirrors in metal. We manufacture mold inserts we manufacture plastic lenses, and we manufacture infrared lenses. The markets that we work on are obviously space and Earth observation. We work on automotive, so completely different application fields, lasers, semiconductor, it's quite a strong field that we are working on, and other applications as well. So we are going now straight into the space applications. I'd like to share two typical geometries that we have been working in the past on. One on the left you can see is the classic Cassegrain design. So I'm taking these two applications from the satellite communication systems that have been mentioned earlier as well. The classic, the laser-based communication systems. The Cassegrain design on the left, and the TMA, the three-mirror anastigmat, on the right. The Cassegrain design is typically using symmetrical mirrors, so it's quite a, let's say, conventional, simple design. And the assembly structure, and these together form the optical system. And on the right side, you can see that the TMA, which is composed of three mirrors, and typically they are non-symmetric and quite difficult to align towards each other. But the benefits is that it's optically very, very clean. You have no spherical aberration, no coma, no anastigmatism. It's very compact and very light. We have heard today that these are two features very important for small satellites. If you think about metal mirrors, they can be made very light using aluminum or lightweight metals, and therefore this, I think, is a very suitable application and suitable design for space communication systems. So Sonics can work on both of these designs. We have made a few of these, and we are currently working with the customers that use these optical communication, or that manufacture these optical communication systems. What do we offer? We start with the optical design together with our customer normally. We can then offer the full manufacturing chain from the block of material to a finished sub-assembly of optics. We do the pre-machining, ultra-high precision manufacturing. So we create the optical relevant surfaces. We manufacture the relevant surfaces for the assembly, which is also important, not just the optic, but the full assembly. We do the coating. Different reflective coatings can be applied depending on the wavelength of the light that you use. We do the qualification down to single nanometer digit surface qualities, and then the sub-assemblies. And I think the most important thing is that we can support our customers from single piece prototype iterations where we make one piece. You can test it, iterate it, improve the design. And then once it's finished, we can scale up and think about, we're talking about maybe a few millimeter to maybe 100 millimeter size components. We can scale these up to a few thousands per year if necessary. Here, just one example of one mirror that we made in the past. It's a 500 millimeter aperture off-axis parabola. We have put this on the machine on axis, so it will be treated as a free form while it's being machined. And on the right side, you can see the surface quality after ultra precision machining. You can see very clear lines on the surface. They can be removed by a post-polishing operation. But if you keep in mind that we want to be economical when it's being applied for the new space applications, it should be as cheap as possible. And we have here surface roughness in the range of 2-3 nanometer SQ. This is normally enough for those applications. The form accuracy that we can reach on such mirrors is in the range of a few 10 nanometer RMS PV, or global PV in the range of a few, maybe 100 to a few hundred nanometer PV, depending on the size of the mirror. Why are these mirrors so beneficial? It has been mentioned before. We are very flexible in the term of the geometry. We can make aspheres, parabolas, off-axis metal mirrors, and freeforms. Even microstructures or diffractive surfaces are possible. The mechanical features, in order to align the mirrors towards each other, they can be manufactured in the same setup. So the optical axis and the mechanical assembly pieces are aligned very, very accurately from the first step. So the alignment of the system can be done very efficiently. The mirrors are lightweighted due to the nature of the material, which is always important for space applications. You can apply the coatings. And quite a fast turnaround is possible in terms of such mirrors. In the beginning, we will be talking about maybe 1-2 months. And if it comes to larger numbers for a stable process chain, we're talking about weeks for making these mirrors. So I think this is quite a difference towards the silicon carbide or the glass-based mirrors. Yes, so we at Sonics, we offer ultra-precision metal mirrors from prototype to high volume. And we are looking to work together with those companies that integrate such metal optics into optical systems and that are looking for companies to supply these mirrors in a good and stable quality. And yeah, so I would look forward to collaborate with those of you who do that. Thank you very much.
Thank you so much, Benjamin. That was a really nice talk. Let's see. Do you have, first let me ask the audience, do you have a question for Benjamin? Yes. But I was happy that we have today John with us from Lambda X. It's an EPIC member.
Mm-hmm.
Hi, John. How are you?
Hi, yes. Good morning to everybody. I have a question related to the level of qualification of both coating and mirror for space application.
So what exactly is the question?
I mean that it means that you have an heritage for the use of your technology in space.
Yes and no. So we have a similar heritage working with Fraunhofer and delivering these optics for space applications. And the coatings are qualified for space, yes.
Okay, very good.
Thank you, and thank you so much for joining us as well. We have another question from Sphericon. Angela?
Yes, can you hear me?
Yes.
All right. So there's always a question about lightweighting back structure in space, and especially in new space, because we need to save weight. And I don't know if there is any, how to say, lightweighting structure also for aluminum mirrors, if possible, as for Zero-Dur, for example.
Yes, absolutely. Well, it's a good question. The lightweighting is definitely very important for these optical systems in space, where every gram costs a lot of money. Due to the nature of the metal, you have to do a careful design of such structures to not have any vibrations or any, to not touch any one of the resonant modes of your optical system. So there's no vibrations later in their use. But yes, the lightweighting is definitely necessary and definitely done on aluminum and metal mirrors.
And can I ask another question? Do you do this before or after the optical surface structuring?
Not sure what the real question is.
No, the question
behind
is
that, but
yeah.
Yes, I understand. No, let me answer in general. The optical surface is probably the most sensible surface on your component, so we will try to avoid any process after that.
Okay.
We are all curious because we have a company from Italy and they are wearing these beautiful masks. Marco, thank you very much for joining this afternoon. I know your company very well, but maybe the others don't. What does Aerospazio do for the rest of the community, Marco?
So, good evening to everybody. I'm sorry for the mess, but
you look
I'm on open
fantastic.
space with some colleagues, and so we have to take some precautions. So, Aerospazio Tecnologie is a company, it's a small, medium-sized company. We have around 40 employees, and it's a company which has a historical expertise in doing diagnostics for electrical propulsion for satellites. So I recently joined the company with other colleagues which have expertise also in photonics to start developing diagnostic systems for this kind of propulsion systems. So it is important to test these engines for satellites without making invasive measurements. So we have large test facilities for space applications. So we have very large vacuum chambers, for example, where we test our engines. And we're also looking to the possibility to start new activities also in the fields of communication for space. For example, this is what I did for many years when I was at university. We also have a few scientists with expertise in spectroscopy that could be maybe interesting for space application in general. So we decided to join today to see what's going on in Europe.
Marco, two things. The first one, I want to come and visit you as soon as the whole virus thing is over, because I heard the kind of qualification that you can do. The second, we are looking for partners in EPIC to help companies like Ligentech, like Lionics, like Photonics 42 qualify their technology for space, or help them understand the reliability or understand the strength of the technology for space. That's something that you can do for us on that.
Yeah. This is what we did usually, is our background. So we have a very large production line in Siena. There is a large terme, so it's all very nice to stay. And we just recently started a new location just devoted to research and development of these diagnostics systems. So I think you are more than welcome to come to visit us, and also all the other colleagues attending today here are also welcome.
I am very skinny, but I eat a lot, so prepare some good lunch if I go there so we can eat fantastic Italian food together and shake hands. I cannot wait for this. Sana, back to you.
Thank you so much.
Thanks.
So I am particularly happy today to introduce Andrea from OHB in Germany for a personal reason, because my husband works at OHB, but also because we are very looking up to this company, and we hope to hear a lot of possible collaborations with OHB today. Jose, can you help me unmute her? Perfect.
Should be good now. No, thank you very much for inviting us. Actually, we have been monitoring EPIC for some time in the background, so it was very good when we received this invitation. And even though it was in the last minute that we prepared everything, we're very happy to be here. So one first thing, why OHB is in this new space meeting if we were not part of the list that Iain McKenzie showed, or we're known as one of the top 3 big industries in Europe, and therefore not new space. So let me show you a picture, if this works. No. So this is actually OHB back in the 80s. We were a startup founded in a garage, like many of the startups now in the US that now they also claim they're part of new space. And we like to call ourselves that we are a startup with experience of life. So I want to highlight this because this is all startups that you are here, or not only startups, but also SMEs or smaller companies. And I want to highlight this because at OHB, even though now we have grown, we still understand very well the struggles. We still understand very well what it means to be a smaller company and fight to grow your business. So we're very open to talk to smaller companies and open to give good opportunities to companies that take risks and fight for their business models. So said this, at OHB, we cover the full range of applications and domains in space. And actually for all of them, I think photonics and optics in general, it's one of the key technologies. So there's no time in 6 minutes to go in detail for everything. But if you have any technology that you're maturing that would fit in any of these domains, please contact us. We want to know what is at the high end. Also, new space. So new space is not about a smaller company or a new company. It's about the way we work. So Iain McKenzie also showed what new space means in terms of definition. It means taking more risks. It means using more codes. It means also the work culture. And at OHB, since we have this background of a startup in a garage, we would try to be flexible and try to basically adapt to this new way of working for new space. So we're also very welcome to listen to you on the technologies. Maybe your technology are not space qualified yet, but maybe they are the best ones. So please come to us. We certainly like to integrate those in our systems. But today I want to talk using my other hat that I have in business development on the quantum technologies, because that's a topic that maybe not many of you know that we are working at OHB. You know us for sure for navigation with our Galileo systems, telecoms, Earth observation, but maybe you don't know that we're also working in quantum technologies. And actually, photonics is a key enabling technology for quantum technology. So what do we do at OHB in that area? So our goal that has been for the past years was to establish OHB as a major systems partner in the realization of quantum technology systems. We have been hearing about the second quantum revolution that is happening right now, and we know quantum technologies are very much focused within the research or academia in the research domain in the labs. But now it's the time to do the jump, to do the industrialization of those quantum technologies. And that's where OHB also wants to play a role. So we established the Quantum Technologies Working Group in 2016. It was supported by our team in systems engineering, business development as well, our team in pre-development. And we set three main topics that we were going to focus. One is quantum communications, especially quantum key distribution, cold atom sensors, basically sensing, atomic space clocks, and optical frequency comms. And for sure, you are the expert here more than me, but I'm sure all of you are thinking like, I have this technology that could apply to this domain or the other. So please contact us. And I want to highlight this as well, because I don't know if you have realized or not, but in the past years, in the past 3-4 years, with this second quantum revolution, we have seen also big interest from the customers, from ESA, from the European Commission, where they launched their quantum technologies flagship. Also nationally, I'm talking to you from Munich, so also DLR and our ministries, they have seen the importance of developing quantum technologies and bringing in quantum systems, where certainly photonics are elements of those systems. So answering the questions, what can we do for you? Basically, we can exchange ideas on business opportunities within space systems. Again, OHB is a space company. We understand we have experts that understand the technologies, but you are the experts on those technologies, on the high tech, on what is the state of the art. So you have to come to us, talk to us, and exchange on where those business opportunities are. We can as well provide you some guidance on how space projects work or what is needed for space. We can help you define some requirements. We can space qualify or help you space qualify your technologies. And of course, eventually, potentially become a partner or a customer. And what can you do for us? As I said, please tell us which are the latest news on the technologies you are developing. Either they are space qualified or not. As I said before, we're very open to the use of COTS. That's where we need to go. It's more important that we can miniaturize and later work also on the space qualification of those technologies, rather than just be crazy about, oh, if it's not space qualified, I'm not gonna talk to you, not at all. But as I say, you are the experts, you know what is your development, so you have to tell us, because it's very difficult to stay on the state of the art on these technologies. And as I said, actively tell us as well how you think your technology can be incorporated into our space systems and the benefits that incorporating your technology can bring into that system. Because we talk to many potential partners. Everybody says, I have this technology, but it's important for you that you tell us, I have this technology for you because this is the benefit that we see that can bring to your space system. And that also will mean that you can become our provider or part of the supply chain or a partner, that's for sure. And I just want to mention, I'm happy that Antwerp Space was also part of this call, because OHB System is the company in Munich, but we're part of the OHB group, where Antwerp Space is also part of the group. So there is a lot of exchange there into this area. And for these particular topics that already Hakimeh talked, they are the experts, and we also talk to them, and they can guide us on what is needed. So there's a good exchange there. So I think that was the 6 minutes.
That was perfect. Andrea, you are epic.
Okay.
It's her first ever presentation at Epic, and she already had the slide. What can you do for us? What can they do for you? This is really great. I always want to hear from system integrators like OHB. I always want to hear the Santa Claus Christmas list. If you could have anything possible or impossible, what would you ask us?
Oh, impossible or impossible. I mean, what we ask everybody is, or any supplier to us, is like, okay, space qualified, that's basically asking for the Christmas gift. If you already have a space qualified technology, that's the best. But miniaturization, that's for sure, miniaturization, but that doesn't mean like lowering on the accuracy, for example. So we want the best. So as we say in Spanish, the 3 Bs, bueno, bonito, barato, right? I don't know how to translate, like good, cheap, but good cheap, like cost effective. Okay, let's not call it cheap. And pretty. So that's also the miniaturization side. But that's basically what ideally we would like to have.
Good, cost effective, and pretty. Pretty definitely, because my friend Michael is very pretty. But Michael, we've been talking a lot about quantum technologies, a lot in the past, and about the use of photonic integrated circuits for quantum technologies. Now we have OHB saying that they are looking at quantum for space. Is there anything you can do with Andrea to do business here?
Yes, I think bueno bonito barato can be done if it's in the right scales, or if you take into account that, for example, going to integrated photonics, you save a lot on launch cost afterwards. So at the LIDAR we do integrated low loss silicon nitride. And that can be used for 2 cases, what you mentioned. One is, for example, you can generate photon pairs for quantum communication. But on the other hand, you can also generate frequency combs on a chip that can be used to stabilize clocks and also for quantum measurements. So there is definitely space to develop further on low loss photonic integrated circuits with silicon nitride.
Mm-hmm.
You're on mute, Jose.
Let me see. Andrea, I'm going to take you to Enschede because it's a beautiful village in the Netherlands. I don't know if you've ever been there. You have to go. Ionics International has a sister company called Quix. Is there anything that in the quantum technologies we have learned that we could tell Andrea for quantum photonic integrated circuits and space?
Yes, so as Michael already said, silicon nitride is a nice platform for any of these applications on atomic clocks, and so because you can capture all the wavelengths that are needed for that below 1 micron. So we spun out Quix as a company to really also look into that and to look at quantum key distribution and to have a system of quantum key distribution as of 2 years ago, I think, with Hans van der Vleck, who you already mentioned as a running CEO now. So yeah, so we have some heritage, and we are teaming up with Quix now to have them look at the end user and the market to come up with their products, and us as a supplier of the technology. And of course, we are working with you already with Antwerp Space on the Space Beam project.
You should know that also that Sana and me, we both have background, actually PhD on quantum technology. So we are really very, very passionate for this. And the first week of September, we go to Glasgow and have our World Quantum Technology Summit, in which Andrea, you are hereby invited to give a presentation and tell us what you want to do in quantum. A very good friend of mine, I love when friends get to know each other here. It's a group of friends. Kasia, how are you doing? Cześć. Kasia is my good friend at Airbus. Kasia, so far, we already have run through the 80% of the meeting. What have you seen so far? What kind of things have resonated with you? What kind of collaborations you can do after this meeting?
Oh, well, I've seen plenty, lots of interesting topics, and I actually been working in the background and sending some a request for contacts already. So yeah, great. Thank you for inviting me.
Kasia is epic, and I'm so happy to have you in this team. Things are great when you have the system integrators already engaging with the companies during the meeting. And I go to the next presentation, I go to Cailabs, I go to the beautiful world of beam shaping. Thank you very much for being here all the way from beautiful north of France. The floor and the attention of everyone is yours. Let's go to presentation mode.
Thank you. Do you hear me?
Yes, loud and clear.
Okay. And this should be it. And you see the slides.
You are sharing the wrong slide. We are shaping the light on the wrong screen. So maybe you can just unplug the secondary screen. You don't need it. And we're in business. The floor is yours.
Okay, thank you very much. So first of all, I would like to thank very much Epic and the Epic team. I mean, these meetings are really amazing. I don't know how many would participated too, but I think it's a large number. So thanks a lot, all the team, Jose, Sana, thank you. So at Cailabs, what we do is optical beam shaping. We have a unique technology that is named multiplane light conversion, MPLC, that enables us to manipulate very, very precisely the shape of the light. There are some examples of shape that you see here. We did some square flat tops. This is interesting for active imaging, for example. This one is a Hermit Gaussian mode. It's interesting for fiber communication. This one is just for fun, basically. And at Cailabs, what we do is really manipulating the shape of the light for a lot of application. We do application in optical beam, in laser processing, for example. We have application in fiber optical network when we increase the throughput of the light. We have application, for example, in optical cables for airplanes, a lot of things. And the one that I want to talk about today is the product that we call TILBA, that is dedicated to laser communication. When we talk about laser communication, there are several limitations, several problems, of course, and the main one is atmospheric turbulence. When you have a satellite that discusses, for example, with a ground station like this, you have a large modification of the wavefront profile. And what we try to do is really mitigate the influence of atmospheric turbulence. And also, because the phenomena is more or less the same for us, we also try to mitigate, to compensate for pointing error inside intersatellite links. What do we offer more precisely? We have several product lines on TILBA. The first one, the more mature probably, is the one that is dedicated to turbulence mitigation on the ground at the receiver side of the ground station. The idea is to have a passive turbulence mitigation, adaptive optic free, with a standard plug and play, easy to integrate component. The concept is relatively simple, even if it's a nightmare to implement, but the idea is that we have a perturbated beam that we decompose into a limited number of modes that we couple to single mode fiber, and then that we recombine to one single mode fiber. And for the customer, the idea is really to have one perturbated beam coupled to one single mode fiber. So the question before, there was a question on how we can couple to single mode fiber. The answer is here. And then we can have this component for other applications. If we think about pointing error in intersatellite link, the physics behind it is exactly the same. When you have a pointing error, you can decompose it into a limited number of modes of shape that we similarly couple to our TILBA and couple then to a single mode fiber. It's also a passive component. The concept is exactly the same. The only thing that is, I would say, small details, is that we have to have a space qualified component. We know that our components are already qualified for airplanes, So there are a lot of similarities between the two, but there are of course also differences, typically when we speak about radiation handling and basically radiation and vacuum. The last product I wanted to talk about is something for the emission. It's a beam combiner. The idea is that we want to put as much complexity as we can on the ground. And so when we have a link from the ground to the satellite, we want to put complexity on the ground. For that, one solution is to have a lot of power at the emission to be sure that you receive something on the satellite. And what we do is couple several sources, a lot of sources, stack them together and have a very nice output like this one to be, and that has much more power at the emission and to ensure high power sources at the emission. So the question that Jose always asks is, what do we need? The first thing, I think the more important for us is a top tier industrial who have a clear roadmap and who tell us very precisely in 2, 3, 5 years, I want to be there. I want to have this throughput. I want to have, I don't know, WDM or not. I want to have this size of telescope. It's very important for us because it gives us the opportunity to have a clear roadmap on our side. There are also other challenges that we are interested in. We are very technology-driven technology, and we always like people who come to us and tell us that they have very complicated problem. I don't know if you, for example, you want to point at several satellites on the same time and with this type of telescope, and you don't know how to do it, come to us. I don't know if we can do it, but at least we'll give a shot and it will be really interesting. Also, we are very interested in understanding more precisely pointing error compensation in inter-satellite link. Because when we talk to satellite integrators, some of them tell us, yes, it's what you propose is very interesting, and some others tell us, no, it's not interesting at all. So what we want is really to be able to understand what are the problem, what are the challenges in inter-satellite links, and what we can do with our component on beam steering and pointing error compensation. Also, we're interested in partners. Something that is very nice and that we can do with our component is pre-compensation, but we cannot do it alone. So for that, we need some partners in research or industry to do that. We also need, we are also, of course, interested to implement our error-free turbulence mitigation in ground station, and anyone who is interested in QKD with OAM, because OAM is something that we can do with our multiplexer. The last thing, because we always need suppliers, there are at least 2 things that I'm really interested in at the moment, is to have fiber ribbon and fiber array that are very, very well tolerant, and also back illuminated photodiode array. So if you know people who have this kind of component, I would love to be in touch with them. So thank you very much. And if you have questions, I'm open to it.
Thank you so much, David. I will leave the floor for the audience. Do you have questions for David? Yeah,
I have one question.
Yes, please.
So regarding this pointing error compensation that you showed in your slide, can you share some info about what polarization it takes and what is the weight and size of this component that you have?
So the technology itself, the MPLC, is polarization agnostic. So it can take whatever polarization you have in the input, and then it doesn't modify the polarization. Of course, if you have a single mode fiber at the output, you need to be sure that if you want, for example, to maintain the polarization, you have a polarization maintaining fiber. So the component in itself is polarization agnostic, but fibers are not always. Then when we talk about the size of our component, when we have standard component for telecommunication on the ground, the size is approximately half a smartphone, so this size approximately. But we are doing some development with Safran to put our component inside airplanes, and for airplanes compatible component, then the size is closer to a €2 coin. But I don't have it here, sorry, but more or less this size for the smaller one. And we tested it on vibration, shock, pressure, temperature, and it handled all of these factors. Of course, it's not space qualified, as I mentioned, because we didn't test radiation and vacuum.
Okay.
But it's something, it's more or less glass blocks and mirrors. So of course there are challenges, but it shouldn't be impossible, at least.
Yeah. Okay. Thank you.
Thank you.
Thank you so much. And please allow me to go back to Andrea for one, because we got questions on YouTube and they are delayed to our live talk right now. We have a question from Celios, from the company Celios, from Thierry Berthoud. And the question, and they say that they develop multispectral filters to be placed on any pixelized sensors, and some are currently being qualified by CNES. So the question is, are you looking for payloads as multispectral imagers?
I would say yes. Okay, as I said at the beginning of my presentation, OHB is a big company, so we have also dedicated teams for each of the domains I presented at the beginning of my presentation. So we have a team on Earth observation. So my answer will be, please send me an email, andrea.jaime@ohb.de, and certainly I will pass the technologies you have to the right colleagues in the company.
Thank you so much. So Andrea was generous putting her email on the chat channel for the private Zoom meeting. But if you are interested in one of the speakers, or you want to contact someone, you can shoot an email to me or to Jose. And Jose is amazing in connecting people like a spider. You can just tell him, and he will let you know directly the right person to speak to and how to do it. Okay, so thank you so much for the talk, David. Very nice. So I would like to go to our last talk by aXenic, by Stefan. Stefan, thank you so much. We're looking forward to hear you. You so respected the rule of 3 slides. It's amazing. Thank you. Okay, I think you're muted.
There we go.
Excellent. Now we can hear you.
Okay, you can see me.
There you go. Thank you so much.
Great. So thank you very much for the invitation to participate. I'm Steve Clements, and I'm the CEO of aXenic. And I would like to tell you today about how we're using our more than 20 years background in telecommunications and applying it to critical components for new space, specifically in high capacity satellite communications. So let me, oops, just find out how to change slides. Okay, so aXenic originated less than 5 years ago, and we specifically set ourselves up to address the space business for high capacity telecommunications by satellite, after working for many decades in high reliability telecom devices. Indeed, our chief engineer originated our components for aerospace more than 30 years ago, before they became used in the telecom area. Our optical modulator is seen by many of our customers as a critical component for enabling high capacity networks, because it's required for intra-satellite communication to manage the data that's required for beam arrays for communication with the ground, but also perhaps the nearer term application for inter-satellite optical beam communication at high capacity. So what do our customers really need in order to make this work? Well, we've heard about size and weight being a key requirement from customers, and our devices are based in the semiconductor gallium arsenide, and that enables us to use very small chips, which gets us to a very small size and therefore weight for the optical modulator. But the gallium arsenide also allows us to fold the optics, which allows us to halve the volume by getting the fiber handling all on one end. So we have both the input and the output fiber handled at one end instead of occupying both ends, as is more traditional. And then a third benefit is really the capacity of these laser communication systems is going to be driving bandwidth. So we are picking up at the bandwidth of current and next generation systems, but we already have these products capable of bandwidths in excess of 50 gigahertz, and we have development roadmaps out to 100 gigahertz. And then we've also heard about size reduction miniaturization, and often integration is the route forward here. And our chips are able to be further integrated, and we can pack, for instance, arrays of devices into the same package, which would allow us an order of magnitude size reduction over current state of the art. So there's plenty of advantages, and these are providing quite compelling reasons for our customers to engage with us. But the other key requirement from our customers, particularly in new space, is to address cost. And one of the problems that's existed for components like optical modulators is to actually keep the cost down. And our approach, we work largely fabless, and we use a route which takes advantage of our old telecom subcontract model. So we're able to use the very high volumes that are available in the foundry and the very scaled and capable assembly routes that have been well established in the telecom arena, and bring that to the new space area. So we're able to produce something in relatively low volume that you use in new space, but take advantage of the cost efficiency of very high volumes from telecom foundries. And likewise for the assembly. So we're confident and we're able to demonstrate to our customers that we can meet the cost targets. It also means that we can scale very easily, because often in old space you were producing small numbers, and the difficulty then was scalability. In our case, we're actually scaling up to something closer to the capability of some of the subcontracts that we use. So to address the Jose question of EPIC, what can people do for us? I'm highlighting three areas. We have long-standing foundry and assembly partners, but we're always keen to talk to foundry and assembly partners that could help us to further develop our capabilities and introduce further integration. But I also mentioned that we're moving towards higher frequencies. We're already at 50 gigahertz, that's fairly challenging, but to get beyond that, test is both expensive and technically challenging, but also the packaging requirements are particularly keen as you go anywhere in those sort of regions. So talking and working and being supported with partners in that area is of great interest to us. And Iain, right at the very beginning of this afternoon, was talking about qualification and reliability, and saying that photonic devices are rather exceptionally qualified in this area. And we generally work with our system integrator partners to qualify our parts for their systems, because those standards and qualifications are not in place. But we believe that we will need to build background here. So those with evaluation and service capabilities and reliability, I think, are an area that we will inevitably need to chase up further in the forthcoming future. And then if we're looking at what we're doing for our customers, hopefully you've been able to see that we have some unique skills here, but we already have some excellent traction with major satellite customers across Europe, and increasingly now across the world, so outside of Europe. We do have the skills for design, but also right across the board for producing in volume. We have backgrounds in volume production from our telecom days, and expertise in packaging, chip design, and so on. So this is a fully rounded team. And we have the business model which addresses price. So apart from those achievements, the prime requirements that were being talked about in the microwave photonics EPIC meeting were really performance-led, but hopefully you've seen that we can address the size, weight and power swap activities. We've got the bandwidth capability for now and for the future. And another key item that I want to remind everyone of, we talked about radiation tolerance right at the front of the meeting, and our gallium arsenide based chips have a reputation for radiation tolerance, and they're already being used in space in optical solar cell and electronic devices. So they are comfortable for applications in space. So that's quite a quick whiz through. You can see my contact details there and be very willing to talk further in and out of this session, but thank you for your attention.
Thank you very much, and I really like that aXenic was here presenting and talking about something that I really wanted to come up at the end of the meeting, which is next steps and what kind of things we can do together. You talk about gallium arsenide having the reputation of being good for space because of radiation tolerance. What kind of partnerships, what kind of collaborations do you think we should do in order to have a more standardization of payloads or more standardization of the kind of requirements that are needed for space qualification of different photonic devices?
To try and give a quick response there, I think that Iain is highlighting earlier on that there aren't many qualified parts, but actually in photonics, there are quite a lot of efforts now trying to standardize the qualification standards for photonics. And I think that that's a clear area for EPIC partners to be engaged in. ESA is leading much of that activity, but there's a place for EPIC partners to be involved in the test standards, the reliability work that's needed in order to evaluate those parts, and indeed to move away from what is mainly laser-based standards, because many of the devices are not necessarily just active current devices like our own, which is actually a field device. So different qualification standards apply for different devices. That sounds a great area for partnership.
Jordi, we heard before from Santi. Jordi is a CEO of Beamagine. Jordi, you are trying to use the new space philosophy to go to space with a new idea, which you very successfully brought into the automotive sector. Is it clear for you which components and which processes are suitable to go into space, or do you need more information from the primes or from the rest of the supply chain?
Well, for us, it's a very good reference what primes, which are their interests and which are the recommendations for the applications. So I don't know, they are using in-gas detectors, or we also using in-gas detectors. So maybe here we have some kind of joint interest on knowing which are the goals for this kind of detectors. For LIDAR or for communications, it's more or less the same technology, the same detector, and the same standards apply to this kind of device. So any recommendation or orientation from the primes would be very good or very valuable for us.
I think, Jordi, should have a talk to Stephen offline, because I do believe that there is a clear connection there for a future of collaboration. Iain, we are almost at the end of the meeting. It's been super cool, by the way, but we are almost at the end of the meeting, and there are two things that I need to address. The first one is there anything that we can do together, EPIC plus ESA, to try to come up with a way of making it easier for the system integrators to define which components they can use for eventually having space qualified systems?
I think Stephen maybe touched on it just a minute ago, saying that maybe the area that we can cooperate is on standardization and test standardization. The only reason I might hesitate is that new space sometimes doesn't want to be encumbered by very heavy standards. And so, you know, it's going to be very mission dependent what sort of qualification standard you would want to apply. So I don't know, I think it's definitely an area of interest. We have, it should be known to the community that we have a photonics working group at ESA, which involves quite a number of industry partners. And in this working group, we're already addressing VCSEL transceivers, for instance, and looking at qualification approach for them. Also radiation testing of fibers, optical fibers, both active and passive. So those are two new standards which are in the making. But again, there is this kind of balancing act between, you know, the idea of being very low cost and having heavy standards.
I have another question, which is coming from the YouTube, and it's for you, but also for in general. So Luis Ferreira, he's the CEO of HVM Fiber Sensing. By the way, we're organizing a meeting at their location, Fiber Sensors. He's wondering what photonic technology will be a game changer in space. And of course, you would know, you maybe not tell us, but what kind of things we need to really invest from a technology point of view? Which are the ones that are attracting most interest inside ESA?
You know, I think one area is AI, artificial intelligence, and how it combines with photonic sensors. This is a real area where I think there's a mine, you know, of potential applications that could pop out of. Because if you combine, you know, for instance, sensors with AI, you can reduce power considerably if you're only looking at what you want to look for. So I think that's possibly one area. We think microphotonics in the long run, though, you know, obviously you need the performance first. Yeah, I mean, you guys have got all the innovation. We're just waiting to hear from you.
I want to hear from Christopher from LabSphere. It's your first ever EPIC meeting. We are almost at the end. We're almost finished. We're almost out of time. But I want to hear from you. What have you learned out of this meeting? What kind of connections? What kind of introductions would you like me to do for you afterwards?
Thanks, Jose. No, it's been very interesting just to see the different cross sections of activity and photonics integration that's going on. Very interesting to see what the priorities are for ESA as well. As far as introductions go, you know, the tack that we're taking in this market is we've always done the ground calibration work and provided flight calibration capability on board the satellites for the big satellites. But for the small satellite community, the new space, we're working on a new global network of vicarious calibration, which will be extremely low cost and very high frequency. And that will be coming out very soon.
John from Optic Balsers, we've been talking a lot in previous meetings about different coatings for space. You joined this meeting. What kind of collaborations do you think we can devise together? And also, what did you learn today?
Well, I joined today. Hello, everyone, at the very end. And thanks for asking me one more question today. I thought I can remain silent, but it didn't work. So, well, we also have a long heritage out of Jena, especially in the Earth observation, like Sentinel program, etc. And we are looking into the whole laser communication area now, because we have noticed there is more activity, more requirement for coatings there. So I was kind of sitting in to listen what's going on in that space, in the laser communication space, and who are the players. So I'm still forming my rough sort of overview of this field.
It's an interesting field. I'm going to finish with my friend Seiya from Joya. Great that you're here and you're looking at the space market. What did you see on the field of optical coatings? What did you see is interesting for you? What kind of collaborations would you like to do with these people?
Thank you, Jose, for a kind introduction. Yes, we as a future supplier are looking forward to get in this market, but our engineer and the production are hesitating due to the very difficult condition. So extremely hard condition to achieve such conditions. So to break such a situation, I would like to know what you are developer to developing the product and to introduce this information to evaluate internally and to develop internal process. That's why I joined today this meeting.
I learned a lot today, not only Seiya, but all of us learned a lot. For me, the first thing that we learned was today, Iain was fantastic on really explaining very clearly what is new space. So I really summarize here. In new space, he said, is the commercialization or democratization of space, which is really cool. And then he told us about the big picture. No, he said it's cheaper, commercial focus. He even said that you have to use lower platforms, but he went below the radar and he told us satellite payloads. We are interested in cameras and spectrometers and miniaturized LIDARs. Then he said telecom payloads. We are really looking at microwave photonics and we are really looking at next generation transceivers, both for downlink and uplink. Satellite platforms. And we said we are looking at miniaturized solutions for inertial measurements. And I think there, Andrea was smiling because quantum technologies for inertial measurements, gyros, is something that is being looked up very, very heavily. And then he saw reusable launchers and space transportation vehicles. And here is when I think I see a great opportunity for the companies in the LIDAR sector. So I think we made a very, very good selection. When it comes to the challenges, I think it's clear to me, the biggest challenge is that we still don't know which components can be qualified, which time to market, and what kind of process we have to do for the qualification. We talk a lot to Thales Alenia. Today we had here different companies who could do the qualification as well. There has to be a way that we can standardize that. But the problem is that Iain McKenzie told us, in new space, the gold standard is not the favorite gold. I think there we need to find a way to make sure, especially for photonic integrated circuits, but also for other optical and photonic components, that we can go into that. Perhaps with the biggest of all, the biggest question of all is the radiation tolerance. Still, test, evaluation, and reliability are something that we are addressing in different frameworks. New space is about using other frameworks in here, so we can really have a huge opportunity to bring all the things that we are doing, especially for packaging and cost reduction of photonic integrated circuits. It was great to see, for example, that there's a demonstrator based on photonic integrated circuits for interrogation fiber optics, which is already been flying in space and is by an EPIC member Technovis, and I took this picture courtesy of ESA. And for me, the star of the show today was Andrea Jaime. I think it was a fantastic presentation. I borrowed this picture because it really summarized all the kind of things that have been done in space, and you really were very clear on this. It is new space and space really go together. We need to play, all of us, new space, an opportunity to bring new companies to the space community. And that's what we want to do at EPIC. That, and one more thing, to have a nice weekend. Thank you very much, everyone. It was epic. Until the next time, this is Jose Daguasana. We really had a lot of fun. Keep being happy, keep smiling, stay home, stay healthy, stay epic. Bye-bye.
Thank you so much. Bye.